In this video, we want to see how we find the p-value in hypothesis test. For example, the mean result of data analysis course was 78. After implementing Excel, we want to test at 5% level of significance that the mean is increased. Assume population is normally distributed and standard deviation of the population is known. When sigma is known, we just use z values. When I say mean is increased, it means that the alternative hypothesis H1 is mu is greater than 78. So it is the thing that we would like to be true. And H0, which is the opposite of that, is mu less than or equal to 78. Based on H1, immediately we realize that we are dealing with a right-tailed test. If the Z calculated be 1.24, when you want to find a p-value, which is nothing but the probability related to Z calculated, we see that here the p-value is nothing but probability of Z being greater than Z calculated, because it is a right-tailed test. So it is probability of Z greater than 1.24. In order to find it, we work with the complement of that. So it is 1 minus probability of Z less than 1.24. Why we do it? Because in the table we can just read the probability of the left-hand side of that value. Now we use the table to read this probability. First of all, we find 1.2 and the second decimal is 4. 0.04 is here, so that probability is 0.8925. So p-value is 1 minus 0.8925 and it is 0.1075. Now here we see that the p-value is not less than or equal to alpha, which is 5%. So here we say that we cannot reject H0 in this scenario. So we cannot reject H0. It means that the mean result of the students is not significantly greater than 78. Now, let's test that the mean is changed. So here H1 is mu be less than 78 or greater than 78. So we write it as mu is not equal to 78. Opposite of that is mu is equal to 78. If the Z calculated be 1.24, here we see that based on H1, we have a two-tailed test. And Z calculated is positive, so it is on this side, it is on the right side of the graph. And when we want to find a p-value, which is probability related to the Z calculated, we find this probability of Z greater than Z calculated, which is this area. But we know that the p-value is the double of that. So we multiply this one by 2. So it is 2 times probability of Z greater than 1.24. We just calculated probability of Z greater than 1.24, which is 0.1075. And 2 times that is 0.21150. So this one again is not less than alpha, so we cannot reject H0, and it means that the mean result is not changed significantly. Now let's assume that the Z calculated is negative 1.24. What do we do here? How do we find p-value here? When we want to find a p-value, again we see that H1, based on H1, we are dealing with a two-tailed test. And probability related to negative 1.24 is probability of Z less than Z calculated, this area. And double of that is the p-value. So we need to calculate the 2 times probability of Z less than negative 1.24. So let's read this probability from the table. In the table, we find negative 1.2 and then 0.04, so that probability is 0.1075. And 2 times that is 0.2150. Again, it is not less than alpha. So again, here we say that we cannot reject H0. But if the p-value be greater than alpha, we say that we can reject H0. Now let's talk about another scenario. Mean is decreased. So here H1 is mu less than 78. So H0, which is the opposite of that, is mu be greater than or equal to 78. Let the Z calculated be negative 1.24. Since the H1 shows us we are dealing with a left-tailed test, the p-value is nothing but probability of Z less than the Z calculated. So it is probability of Z less than negative 1.24. So we use the table again to find this probability, which is negative 1.2 here, then 0.04 here, so that probability is 0.1075. So the p-value is 0.1075. Now, in order to make a decision, we compare it with alpha. Actually, p-value here is again, it's not less than equal to 4. This is not less than alpha. Alpha is 5%. So here we cannot reject H0. So you see that here, guys, in p-value approach, doesn't matter that we have a left-tail test, right-tail test, or two-tail test. When we want to make a decision, we reject H0 just if the p-value is less than alpha. But in order to define the p-value, we need to be careful about the test, whether it is right-tailed, left-tailed, or two-tailed. So always I suggest you to sketch the graph to have a better idea about the p-value and define it correctly.